and you can literally build your circuit board with microcontroller systems and sell them after graduate from a startup company. I've been selling products for many years, and not too many of them, but it's been successful. And the bar is low, not as low as computer science. If you've got a laptop, you can program. And you're not getting paid as high as computer science as well. So why should you be here? It's just fascinating. It's very useful. It's interesting. It's great. But still, the pay is great. Usually, I mean, embedded system engineers, you are expecting 100 to 150K as a start if you are doing well. But for computer science, if you can do really well at the algorithms, usually Google is going to pay 200K, but in San Francisco area. And 5 years later, you're getting $500,000 or 300K. But usually, when the economy goes down, they'll lay off a lot of people. For example, Microsoft is laying off like 100K, or I don't know, probably I'm exaggerating the numbers, but a lot of people has been laid off recently. Facebook, Microsoft, all different places. The bar is low. You get a laptop, you learn on the online courses, you know how to code, you get a job. But hardware is different. I can tell, analog circuit design is the bar is high. Usually they require PhDs. Mixed signal embedded systems, usually it's the bar is lower compared to digital design. Usually undergraduates, if you got a defense job at San Diego or Los Alamos, you can still get 80K to 100K as an undergraduate. It's pretty good, I think. Not too bad. But after the inflation, it's not. But still, it's better than a lot of other majors. Because the industry, there's a high demand. You can always get a job if you know how to design PCBs and embedded systems. Know how to do PCBs is not enough because you have to put things on the PCB. How many of you are in the PCB class later today? 393. 6 p.m. today. Just one? Okay. I thought you guys are in both because it's very similar. No? Or have you taken that class? Are you going to take it? Is that required? Okay. No, it's not required. Anyway, so it's a one credit class, but almost 3 hours on Monday night, 6 to 8:50 p.m. And I think that class was developed by Dr. Carlston. He used the Eagle PCB, and I used Eagle PCB as well for many years, and selling products using Eagle PCBs is fine. It's fine to use open source software, and people are arguing Eagle PCB will be abandoned, will not be used anymore in the industry. It's just being put into Fusion 360, and it's the same interface, no difference. And it's free software. When you are doing interview, if you take the PCB class with me, you are not, just one, anyway. So in the future as well, I'm pretty sure Dr. Carlston will teach the same materials in the next few years. If you learn Eagle PCB, don't feel bad, it's good, actually. If you got some PCB products, when you are graduating, do the interview, tell them what are the cool products you have developed, you can get a job easily. That's what my students have been doing. The employee rate, if you have like 5 to 6 PCBs before graduate, the employee rate is almost 85 to 90% at the Ford. And the starting salary is almost 85K at least. And most of them find jobs in San Diego and Los Alamos. I think it's going to be the same situation, or even better here. It's School of Mines, it's the best school in Colorado. I think you guys are learning the correct things with the correct professors, so you guys are lucky. PCB design, not every institution is teaching that at this intensity. I mean, for this college, like I'm teaching the same way. I think Dr. Carlston, just by chance, we didn't know each other before. And he's teaching PCB design the same way, and even more intense. So you guys are lucky, I think. And for embedded systems as well, people know how to do Arduinos, and I taught ESP32s is Arduino interface. And industry, people are using STM32s or ESP32s, sometimes AVR or Arduinos. It's easy to prototype. You have a lot of libraries available online. You can directly load the libraries and start programming. You can get a display within like 10 minutes by using libraries. You are using the PIC, which is what we are using for this class. It takes probably 30 minutes, but you can still get it done. So the question is, why do we have to use PIC for this class, not Arduinos? I sold my products with Arduinos. It's okay, Because if you are loading the libraries, you are not able to access the registers, even though you can. But because you are able to load the libraries, you're just getting lazy. You don't look at the registers. You don't know the architectures. So it's not good. I don't think want to say it's not good because I'm teaching that at the Ford. I think it's still good because you can develop products and sell them really quickly. You can develop, so the turnaround is very short. However, if you're getting something, you are losing something, right? So you are losing the opportunity to learn the basics and fundamentals. Another drawback of using PIC is towards the end of the term, it may take you a significant longer time to develop a decent product. So the course project at the end of the semester, maybe you spend a lot of time, but it's probably just driving a motor and then do some like interesting design with the display, but won't be that fancy. You know what I mean? So for example, if you use Arduinos with the open source libraries, you can develop a IoT network that the product I sold to Puget Springs. It's a hot tub resort. We developed like 25 temperature sensor, put in the network and send it to Wi-Fi. So you can do Wi-Fi with the SP32 tools because the Wi-Fi is right on it. So we don't have Wi-Fi over here on the board. You have to connect a Wi-Fi module to it, and so on and so forth. It takes a lot of time to get it done. So that's something you need to know. If you're looking at other people on YouTube, they are developing really fancy projects. It's not because they are spending more time than you guys. It's just that they have the libraries available for them. Okay, but learning PIC has a lot of advantages. For example, you can touch the base, you can touch the fundamentals, registers, which will be beneficial in the future for what? For becoming a digital design engineer. Okay, so for example, you know the basics, you know the architecture. So in the future, when you get a job in the industry, which is asking you to design a microcontroller yourself, you know how to do it, since you know how these registers works, how to do the comparison, how to do the capture, and timers, interrupts. You know how that works. You just do a similar job with whatever you learn from PIC. And when I was in college, we all learned PIC because that was the only thing available by the time. That was 20 years ago when I was in college. And but nowadays, AVR, Arduinos are gaining more momentum because it's easy to use. And ESP32 tools use the Arduino interface, is easy to use. If you want to make it hard, you can still program with assembly. There's still an open source interface called Microchip Studio, I guess. So you can also program in the hard way if you want. If you don't want to use the libraries, just want to program with assembly, you can still do so. Luckily, you guys are not programming assembly. How many of you have a programmed assembly? Okay, where? Architecture or? Okay, computer architecture. It's even slower, right? A lot of institutions are teaching assembly, I can tell you. That's a killer. For example, 100 students in the classroom. After the first 2 weeks of the semester, you already lost your interest in microcontrollers. So it's not a good strategy to teach assembly, in my mind, for the first microcontroller class. It's just too slow. It's too slow to get some fun. So C is good. Programming with C, fantastic. Standard. The standard way to do it in the industry. It's good. In industry, we'll never get a job. You don't have to use PIC. You don't have to use Arduinos. But most likely, you are using STM32s or other 32-bit microcontrollers. It's very common. Or maybe not microcontrollers at all. It's going to be FPGAs, embedded system FPGAs with the embedded core in it. Have you taken FPGAs before? You have? No? You? No. Okay, let me write it down. Do you know the different layers of computer engineering? Different layers? You have to have a concept about what's going on in the industry. Okay. So semiconductor industry is the key competitive advantage of the nation. That's why the president signed a bill of $200 billion. We didn't hear it wrong. $200 billion. 5 years ago, 4 years ago, to counter the competition from China. And it's just so important. Think about that. Why we have a high standard of life. It's just one part of the food chain. If the people in Silicon Valley are able to design all these highly profitable chips, and they are getting 200K as a salary, they spend that at the restaurant, they are able to afford a lot of things, the housing and everything. So people who sold their house got a lot of money. They sold their house and come to Colorado and buy the house to inflate the price, right? So the price is high, the rentals are high, and you guys, some of the students are getting part-time in the restaurant, right? And they have to be paid higher because they have to afford the rents. So that's why the salary is all going up, because we have that highly profitable industry. It's just one of the sectors in the industry. There are so many other ones, like financial services in the US. That's why people are getting a good quality of life, in my mind. However, if other places are gaining the advantage over a certain industries, so the standard of life will be lower for different places. So, and that's the opportunity for us to learn. Like I said, the bar is low, the bar is higher compared to computer science. So it's not that competitive in some sort of level to some extent. So there are a lot of super smart people are being attracted to Google and they're getting a computer science job. But for the people who are able to, keep in mind, you are smart doesn't mean you are able to or you are capable of doing hardware design. I've known a lot of students, they are super smart, but if they put their hands on a circuit board, they just feel so awkward. They couldn't wire them up and couldn't do anything about it. But if you give them a keyboard, they can sit there for 10 hours a day just typing. That's called computer scientists. And you guys are engineers. I think we can do more things. We can program, definitely. You guys are programming microcontrollers, but also building circuits. So the bar is slightly higher. And if I draw the different layers, MCU design, even lower, So MCU design, and this is CS, computer science, okay? And here's FPGA, here's ASIC, here's nano fab. So you know what are the different layers of the industry. Nano fab is just foundries like TSMC and Intel, whatever. Samsung, these are fabs, right? Fabs. What are fabs?
Fabrication.
Pure play. Yeah, fabrication. Pure is called pure play. So in the past, you can see that, right? So in the past, the Intel at the very beginning was trying to do everything, both fab and design as well. Still doing both. But down to the 5 nanometer level, I think it's losing its advantage over TSMC. So TSMC is probably taking like over 90% of the market right now for 5 nanometer technology. There's one super exciting stuff going on right now. It's happening only in Colorado and only at Forest College now, which is the TSMC 180. I know it's a very old technology, from 2005. I just want to let you know, I'm not trying to brag about it, just want to let you know what's possible, okay, what is possible. TSMC is a foundry. It's collecting designs from a company called Muse, which is a company based in Denver. It's providing MPW, multi-project wafer, MPW, from the whole country, from institutions, from MIT, Harvard, anywhere. And put them on, all the designs on one big wafer, I think it's 18-inch wafer, and send it to TSMC for fabrication. So that's how we can bring the cost down to some sort of affordable level. But still, the only one that is affordable for us is TSMC 180 nanometer technology, which is the smallest node you can make on the wafer. Is that the length or width of the transistor? Have you taken analog? No, electronics, digital? Okay, so the transistor has a, this is the cross-sectional view of the MOSFET, right? And here is the length. There's the length of the transistor. NMOS, right? N-type, metal oxide semiconductor devices, NMOS. So NMOS is the length. So if I'm talking about 100 nanometers technology, which is the dimension of what? the lens. Yeah, I've seen this a lot, right? So 90 nanometer technology, 65, 28, like 5. Now it's talking about what? 2 and 3. And TSMC is the only company doing that. And for 5, now it's already commercialized. It's being used for the chips in Apple, the smartphones. And TSMC is the only company making that good yield on 5, beating both Samsung and Intel. So TSMC is the only one available. So you know what stock to buy, right? All the NVIDIA chips, GPUs are made by TSMC. All of them. So TSMC collects all the, TSMC is the fab. Mills, we should be proud of it because it's based in Denver. And is a multi-project wafer service company, collects all the designs, the little tiny designs of the chips, put on the wafer and send it to TSMC for fabrication, which will bring the cost down to a certain level. And what's the level? For the cheapest that we can do. For universities, I'm saying, not Apple. For us at the Ford, $6,000 for one design. $6,000 for one design. It's gonna give you 40 dies, 40 tiny chips, same design, same copy. $6,000. So if you move up, or I'm trying to say move down to like 65 nanometer, or even 28, it costs you like hundreds of thousands of dollars for one design. I know mine is rich. I mean, do you think you guys are able to afford that? $200K one design for senior son, what about that? You can, I know you are. Mine's. I don't think so. I'm just joking. But I believe all of us, for most of the institutions, we should be able to afford $6,000K for like 5 students on the team to get a design fabricated. I think so. That's what we do. The students are getting $1,000 for senior sum for each of them. So 5 students will get $5,000, and then I'm going to pay the money from somewhere else to get the $6,000 sent to Mills to get the design fabricated. And that's not the most difficult part. And there are just so many roadblocks, including the server. It's called Cadence. And there's an industry standard design tool called Innovus, and the synthesize tool is called Genus. And it's $4,500 a year for the license. And there's another front design tool called Synopsys. It's $3,500 a year for the license. And it's not even the roadblock. Another roadblock is you need to hire a full-time person to manage the server whole year long to get the students registered to the Linux system. That's why you guys probably have to learn how to use Vim. So I'm gonna let you guys type in Vim. Probably not, since the PIC environment is not Vim. You need to know how to do Vim, okay? For sure. Don't be lazy. Learn all the commands in Vim. Whenever you are doing collaborative design, I mean, embedded systems, it has a lot of demand in the industry. But very likely, eventually, because you are going to learn IPGAs as well. It's the one required class in the curriculum. If you learn IPGAs, eventually, if you get into the digital design industry, and the collaborative projects are always on Vim, on Linux, it's going to be a server hosted in the room in the company, and you guys are logging to Linux and doing collaborative design. And it's going to be Vim. Okay? Learn how to do Vim. Or VI. All right? It's just a text editor. Don't get scared. Someone pay that person $6,000 a year full time to manage the server. Okay? And $6,000 the design sent to TSMC, sent to Mills. And it's still not all the roadblocks. Because 180 is only affordable one for us, for most of us. So you have to use a memory compiler, the RAMs in the microcontrollers, to temporarily save data. So the RAMs, the memories, have to be compiled by a certain tool. You cannot just directly synthesize it using RTLs. So if in that case, this is too big. If you just synthesize it using gates, it's going to be huge. The chip area is super expensive. You don't want to directly just synthesize it randomly. Use the synthesizer. Okay, it's going to be compiled by a certain tool, and that tool is a software from TSMC, and can only run on a 25-year-old machine called Solaris. 8. Solaris 8. And there's only one company in Canada is maintaining that and selling them to any places, which is like $900 a tower, and the little mouse and keyboard cost me like $500. And the connector is even something you have never seen. That one was probably made before you were born. And that's the only company selling these machines. You have to get one of the machines, put in the lab, and get a memory compiler installed. And the Solaris operating system is not Linux, not Windows. You have to know how to use it. And get a memory compiler to compile your memory. Got 2 really nice blocks and put in the chip. And got all your other stuff like cores, counters and clocks, everything in the chip. And put them together, do the timing sign off, put the pads, and eventually send it to Mills. Mills will send it to TSMC, and about 6 months later, you got a chip. And got a chip, still not the final roadblock, not all the roadblocks. You have to put on the wire bonder, which costs like $50,000, and have to know how to operate the wire bonder. Put in the package, bond the wires, the pads, and test it. And got a 90% chance it's not working. Then cry for a little bit in the kitchen and come back, redesign it. Okay? It's hard. That's probably the highest bar in the industry as an electrical engineer. Either digital design or analog design. Analog design is probably the strength of this department. You'll see a lot of people, even IEEE fellows in the department, that are teaching you how to design antennas. It's really good. It's something I don't know much about it. And RF design, got a graduate school, learn how to do it, put on the chip. Analog design is analog, right? But there are just so many job opportunities for digital design. If they're not making chips like what I'm talking about just now, what I talked about just now, it's going to be FPGAs. So you can also synthesize the whole design onto a prototyping chip. It's called FPGA. That's why it's so fascinating. You don't have to go through the Muse and TSMC route. So FPGA called Field Programmable Gate Array. Okay, not a drink. FPGA, definitely need to learn it. Embedded systems, which is microcontrollers. The second level, or the one level lower. See, I'm drawing that. The one level lower, which is the chip design level, but on the prototyping chip, not ASIC. ASIC is called application specific. IC, IC is integrated circuits, right? So ASIC is the chip workflow, like I just told you, the Muse TSMC chip bonding wire path, right? So FPGA is different. FPGA is just a board, like microcontrollers. You have a big chip on it. It's not as microcontrollers. It doesn't have all the counters, clocks, and timers, and it's just it's not empty. It's not programmed. It has all the gates with all the interconnections. You program it. You synthesize it, and then you implement your design onto that chip. It's a different architecture. However, eventually you are making a ASIC on FPGA, not a dedicated chip. So what's the cost of it? It's just the cost of the board. $200, you can buy one. If you want to learn that earlier, highly recommend it. If you want to learn that earlier, just purchase a board from Digiland. Digiland, I think. It's a company selling all the Xilinx. Xilinx FPGAs. And you are using a language called Verilog or VHDL. It's a hardware description language. And Verilog is more popular in the US. VHDL is more popular in the Europe. But they are doing the same thing. Verilog is easier to write. If you learn one of them, it's easy to translate to another one. But I recommend Verilog. But you are going to learn VHDL later in the college. So it's okay. Very simple, very similar. So learn how to write it, program FPGAs, get ASICs, and get a digital design job. So there are a lot of opportunities over here. The bar is a little bit higher than MCUs, but a bit lower than ASICs. Okay, a lot of jobs. So you need to verify your design before you send it out. Like I said, it's expensive to fabricate a chip, right? So it's better to verify on IPGAs. Verify the hardware, the timing, before you do the real ASIC. You can verify, you can reprogram it for millions of times, no problem. So you want to learn ASIC, I'm pretty sure you are going to learn VLSI design over here. Take it, highly recommend it. It's just covering all the layers. I saw a semiconductor class in the curriculum as well. So take it, be serious about the materials over there. So you know the bottom level, the ASIC level, VLSI, the IPGA level, the MCU level, system level, PCB level, and the CS level a little bit. I'm pretty sure you guys are taking some CS classes, right? Algorithms, programming. Okay, these are all helpful. So that's pretty much the ecosystem of the entire industry. And I would say MCU embedded system designers are getting like 85K to 120K. IPG and ASIC are probably getting 120K to like 180K. There are exceptions, but in general, nanofab can be like 70K to like 110K. CS is different, right? Because they just need a keyboard. And all of these areas are fascinating. You should learn all of them. Okay? Now, let's talk about the class. Easy money to earn, right? Teaching. Anyway, so this is recorded, keep in mind. I'm going to post the lectures over here. I'm going to just click this link. So where is the website? What's the URL? It's electronics. First name has first two letters, YI. I'm going to write it down here. YI, lec1.com. Pretty good domain name, isn't it? Want to buy it? So click embedded systems. So I think because the grader has to grade it through Canvas, so I'm going to post the assignment to Canvas as well. I haven't done so, but I'm going to do it. There's no way you can submit to my website. So she's going to grade it in Canvas. Okay, so the classes are already, for the first few weeks already in there. And you can see all the plans. And might change depending on like the progress. Let me see what I want to say. So the website assignments will be, I think, once a week for homework. These are just some problems on the website. You can see that Dr. Costin, who is on sabbatical as well, and there's the website he created. Since I'm using the board at Mainz, not Arduinos, so I have to learn and develop everything myself. Go through that from scratch. If I just teach what I have been teaching, it's going to be so easy for me. I'll just lay on the beach. It's a little bit more work for me, but it's okay. So I'm not adopting every single thing from the website. I'm trying to make it more straightforward. So you see the lectures. If you click, you can see the lectures. The lectures has questions. And, but I made it, I think, more specific on my website. I mean, this is awesome. He just posted everything on the website. But let me tell you what I'm doing here. So his website will be used as a reference for you guys. Keep in mind, as a reference. So if you see the questions at the bottom of the page on his website, some of them probably you don't have to answer them on your assignment or report. So just refer to this one. I'm going to post it. I'm going to post it to Canvas as well. So for example, homework 1. And that's everything you need to do for homework 1. Okay? Don't go to the website and do more. You're welcome to do so, but it's going to be extra load for the grader. So I extracted the most typical and important ones from the website.
Do we have labs this week?
Yes. Good question. So usually we don't have labs for the first week, right? That's what I heard. But I think for the teachers who already taught this class, they told me we should have class for the first week. It's a very simple class, very simple lab though. It just run the demonstrations. It just follows the instructions. It's going to be easy for you guys. Not too much programming, just directly downloading. I think it's good for you guys to start working on that for the first week because you get everything set up. You got the software, the compiler installed on the laptop, and you know what to do for the next week. Okay, so you are not creating any programs for the first week. It just follow the instructions. And what I did in the summer for a few weeks, I followed the instructions on his website, and it all worked. Most of them worked. So, but actually, sometimes I was thinking if I teach it, I want to change this and that. Okay, so, but I don't have access to the whole website, and I don't want to just change too much. So, for example, he comes back in the future from sabbatical, and he doesn't like my changes. Okay, so what I did was I posted all the steps. When I was doing the lab myself in the summer, I made a snapshots and recorded all the steps on my website. So you will be able to see here. See week 1, right? Week 1 has 1, 2, 3 lectures, Monday, Wednesday, Friday. So Thursday is the lab. Okay, click lab 1. It's a lot of work. So I'm serious. Okay. The good thing about this is it shows all the steps. You just follow. Okay, it's not a long paragraph saying do this, do that, you'll see this, you'll see that, and then with a question in it. It's just showing the snapshots. Just follow, okay? If you have questions regarding the snapshots or the steps, you can always refer back to his website and find out the answer. Hopefully you can find it from the website. And I made the tasks very clear to you guys. So it's not embedded into the steps. It's just at the bottom of the page. 1, 2, 3, 4 bullet points. So you know what to do. Okay? So for the lab reports, you have to show the snapshots or demo videos. You can form a group or a team for 2 people, but the reports has to be individual reports. You can share the same pictures. Okay? You take the same picture of the system, you can do the same pictures. But the report have to draft it by yourself. It's going to be individual reports. Same pictures, same demo videos is fine, but has to be individual reports. And you'll submit the reports to Canvas, and grader is going to do the speed grader and click, and grade it. And embed a YouTube demo. It's just a link, right? So you can create a YouTube channel by yourself, or you can share the same channel, so you can both submit the same videos. Like I said, you can use the same demo video for the report. Embed the link into the report. So the grader will look at the calculations and pictures, snapshots, and click the YouTube link and watch the video of the demonstration. So make it clear, because it's not an in-person demonstration. You do need to do in-person demonstration. I'm still trying to talk with the TAs to see what has been working. But for now, at least, you need to submit a YouTube video link to do all the demos in the video. Okay? You want to tell the grader what has been happening. You don't want to just directly be silent, right? Have the LED blinking for 5 seconds and turn it off. Who knows what's happening? You want to tell the TA the grader will not present in the lab. We have 8 TA teaching assistants, lab assistants, will be physically in the lab. However, the grader is not in the lab. The 9th person is not in the lab. So I have to make the video very clear tell her what you have been doing, what you are demonstrating over there. Okay, is that clear? The reason I want one person to grade it is because in the past, what I've heard is we may switch to the bag tradition. But anyway, based on my experience, I want to keep it a same standard across the board. For example, different teaching assistants for 4 sections. For example, you demo to this TA, right? And this TA gave you like 100. And the same job, same work for the section D, only give you like 80. And you'll start complaining, we did the same thing, but why I'm getting 80 is that person getting 100. You know what I mean? I want to keep one person to grade all the demos, assignments, and everything. So the same standard. If she's, I know she will not, but just in case, the grader is surprising the grade, make it super low for everyone, like 50 average for everyone. I'm gonna curse it. How do I say that? I mean, just linearize it or increase it for everyone in the future towards the end of the semester to make it reasonable. The same standard. If it's all 50 as average, probably eventually you are getting. I don't want to tell you that actually. Should I? So you'll get all 50 because I told you if you got 50, you got 80s. No, just an example. You know what I mean? So I'm telling the grader, just one grader, grade everything. What about that? You think it's better than different graders or just one grader? What you think? Either way, you don't care. Okay. Well, try it. See how that works. Okay. Attendance. I'm not counting attendance. It's going to take me the whole class to check attendance. So what I care is you got to work done and you learn something. Okay. If you submit the homework assignments, got a good grade. You show up in the lab. You do the good demonstrations. You show me how to program the controllers. I know you have learned something. Why do I care about attendance? It's better to be here because you can always ask questions and talk with me during the lecture, raise your hand. It's just always nice to do so. Hopefully on Wednesday I'm not just seeing one person basically showing up over here. I know you guys will be here, okay? That's what's been happening at the fort as well. I never count attendance. Lab components, I think for this class, there's a lab coordinator will keep everything in the bag, the sandwich bag, and give it to every single person in the class. So even though you are forming a team by 2 people, but still everyone got a kit. Okay, so everyone's learning. You keep it towards the end of the semester and return it. Okay. Research. Online C compiler. That's something I want to talk about, but don't want to confuse you guys. Should I introduce it? I should, because for the first few weeks, it's always difficult. Arduinos are easy. You plug in, you program, you see the results from serial monitor. This guy have to do all the MCC stuff, to do all the preparation. Takes a few minutes. It's okay, I can do it. I don't have to set up the serial monitor. It takes like 5 minutes. Okay. So when I'm trying to demonstrate some ideas with the C programming, even though it's not directly the same thing as you program with an embedded C, it's going to be very similar. For example, you just want to do a print, just print something. It's the same C compiler, same results. So I'm trying to let you guys use C compiler when you are trying to demonstrate your ideas, but never get me wrong, okay? I just want to take it carefully. I'm sorry about the ads, but anyway, so don't just say that. Dr. Lee is asking us to do this online C compilers, simulators. No, I'm not, right? You know what I mean? It's just something you demonstrate your ideas really quickly. Okay? It's just for some of the homework assignments. For labs, it has to be on embedded systems. Okay? Just for online demonstration. I have the link to the C compiler. You can always demonstrate the C compiler or programming with that board. You just have to plug it in. Takes 5 minutes to compile to prepare it, and then get the results from the serial monitor. However, C compiler will be easier. Okay, online C compiler to practice your C programming, just for practice, not for embedded systems. Don't get me wrong, okay? Just for practice. What else I want to say? I want to talk about. Well, I have a lot of things to talk about. You know, like my projects in the past to get you excited, and I think it's not a good time to do so because we only have 5 minutes left, right? So I want to cover something real quick to see your basics, see if you know the basics. I've taken logic, right? So the two most important class to build the foundations, circuit 1 and logic. Circuit 1 and logic. You have taken both of them, right? So you should know 0x AB, to binary is what? So didn't take logic. I'm kidding. So it's gonna be 0b. I know it's been a while. It's been a while. So 0x is hex, right? It's hex. What is A? 10. Good. Okay, so 10 is A. So to form a 10, you need a what and what?
You need a 1 in the 2 to the third position and a 1 in the 2 to the 1 position.
Yes. So you need an 8 and a
2.
2. So it's going to be 1, 0, 1, 0, right? Okay? How many of you can get this in 5 seconds, let's say? Raise your hand. Cool? Okay. 5 seconds. 10 seconds. 20 seconds. 2 hours.
Do it by then.
What is B? It's just 11. Just 11. 1, 0, 1, 1. Okay? You need an 8, you need a 3. Okay? What is this?
Binary.
Binary. Yes, binary format. Okay? So I'm grouping 4s, right? To form a hex. So some numbers you need to know. What is this in binary?
1 and then 8 zeros or 9 zeros.
Yes, because it's 2 to the 10. As a computer or electrical engineer, you need to know specific numbers for the interview.
58.
Right?
2 to the third.
Okay. 2's complement, really quick. 2 minutes left. 2's complement. You paid the tuition, right? 2 minutes is something. Otherwise, I have to refund you guys for 2 minutes. 2's complement, what is this? Signed.
-8.
Negative, wait, why? Why is that?
Because the first bit is negated.
Yeah. Yeah, I know some of you already forgot it. It's okay. So we will get it in the first few weeks. I'm not trying to do it super fast. We have homework assignments to practice this for the first 2 weeks. Okay? That's I'm gonna meet you again on Wednesday, right? Cool.